Hello everybody and welcome to Arganian's Puzzle Box. In today's tutorial we're going to talk about VDBs and how to use them. Now very importantly, if you don't know, Unreal Engine 5.3 now supports natively the VDB format, which means you can bring explosions, you can bring clouds, you can bring everything that you could generate through Houdini and Embergen in VDB format. You can now bring that into Unreal Engine and use it yourself. So this tutorial goes through that. Now, to make this a lot easier for you guys, I'm offering one of the VDBs from my explosion pack that I have on Unreal Engine Marketplace. I'm offering that VDB for free, so just head on over into the description below into my Patreon page and download it from there. You don't have to actually be a patron, you can just get the file like that. But if you want to support the channel, feel free to have a look on my Unreal Engine Marketplace or ArtStation or Gumroad to purchase the whole pack of explosions. I'm also going to add 2 packs of clouds very soon as well. But what is this tutorial all about? So we're going to learn how to import VDBs, set up the material, what everything pretty much does in the setup, and more importantly, actually, how to do resource management, because VDBs are very expensive, especially when it comes to disk size and performance, so FPS. I wouldn't necessarily recommend them for video games, but if you know what you're doing, you should be okay. So we're going to go through methods of reducing that overhead to allow you to use these VDBs a lot more, with a lot more ease. So it's all about understanding the source material for you to be able to apply it. So that's what this tutorial is all about, okay? So if you really want to learn how to optimize your VDBs, and if you really want to learn how to set them up and use them correctly, then follow along, and I'm sure you'll do fine. Anyway, without any further delays, let's begin the tutorial, shall we? Okay, now we've got our Unreal Engine scene open in here, and this is where I've got my collection of volumetric explosions, and this is one of them playing. This is called the Fire Burst, and as you can see, it's a looping animation that just sort of bursts the fire effect just keeps looping like this over and over again. And there's a bunch of settings in here that we're going to go through when we set up our own VDB. But what's important to note is that this is an animated VDB, which means it takes quite a huge chunk of resources. We can actually look and see what the FPS stats are on this. So about 60, 70 FPS right now. Goes down to like 30 when it reaches its peak. That's where you also can notice a bit of clipping. Now, normally these effects are not meant for real-time applications as such. They are meant for cinematic work and things like that. So what you'd want to do is effectively use these in a movie or something, and then performance won't be as much of an impact, you see. And then also you wouldn't get any of this clipping issue right there in a cinematic, because your performance wouldn't really matter when you do an actual render. Okay, let me just show you a few other effects in the collection as well. And for example, I could open the smoke loop one, which is effectively what it sounds like. It's like smoke that just loops. And then you can also, for example, have a look at this carpet fire, which is, well, again, what it sounds like. It's a carpet fire. You can notice in there, it's just an explosion that builds up and goes up into the air. We also have like a bonfire one, so this is where there's just flames coming out of here. And one of my personal favorites, we have this, I think this rolling fire one is really cool. So this rolling fire is going to be a specialized sort of a VDB that I'm going to show you, where it's being set up fairly different from what we're going to set up today. So that you can sort of see why this is different and why it plays differently and it looks differently from everything else, because it is a different type of effect as opposed to the other effects in here. One thing also, like for example, you could have a look at this firestorm, which we are in the middle of, and it's sort of similarly to that rolling fire that we saw earlier, but it's still using the previous method of generating this effect, rather than what that one was doing, which was a lot more like flames rather than this. But again, you'll be able to see this when we sort of get into that. So let's just begin creating our first VDB. So what I'm going to do, I'm going to actually open the fire burst map again, and this is the one that we saw at the beginning. So actually, I think my camera's stuttering a bit because of the effect of the VDB. So what I'm going to do is I'm actually going to like disable the camera. So let me just do that. Okay, so now I'm going to take this VDB in here and I'm going to delete it. And let's have a look at, we'll create a new folder in here. We're going to call it VDB tutorial. Okay. Double click that and then we'll be able to import our VDB in here. So one thing that I've got a VDB file that we could bring in. And you'll notice that these files are quite big in size. So, 2 gigabytes, 6 gigabytes, 5 gigabytes. And the reason for that is the reason why it's so big is because they are files that contain animations. So every VDB is a sequence and it builds up in a space, disk space, depending on the complexity of the geometry in it. So we're going to bring this one in. And we can drag the first VDB into here, into Unreal Engine, and then we're going to be met with a set of options. It's going to ask us if we want to import the density, temperature, and flames. So basically, you won't see here more options than what the VDB format itself contains. What I mean by this is, like, it really depends on how you export your file from your source program. So in this case, it was Embergen. So I exported density, temperature, and flames. And what you're going to notice here, it gives you two different attributes, and each of these pretty much contain an RGB and alpha. Now you could set these to none, both of them, and then put the temperature, density and temperature up here if you want. Sorry, the temperature and flames up here if you want. And they're going to be under an 8-bit uniform sort of import. But normally you want to bring that to density, you want to bring it at that, and you want to keep these as 16-bit floats. So I'm gonna separate them and actually just gonna put the temperature and flames down here. Now, the more attributes you add, the larger the file size. So for example, if I just bring in the density, the file size would be lower than the 5 gigabytes we saw in that folder earlier. So what we saw, in here basically, because we're only bringing about 60% of the file, temperature being about 35% of the file size, and then flames being about 5% of the file size. So if we bring all these three, that'll be 100% of the file size, but if we bring only the density, then it will just be, as about 60 to 65% of the file size. Actually, in this particular case, we'll bring all three of them, see what happens. So once you've got them all, it says in here it's found a sequence of 111 items. You could untick this and just bring only the sequence that you want from there, but that's really up to you. But we're doing an animation, so I'm just going to click import, and this will take a bit of time, and then after that's finished, we can then look at how to set it up. Okay, now we have our Fireburst file in here, and we need to start using it, but we actually can't until we use this, which is a texture, by the way. So it says in there, animated sparse volume texture. We need to use that in the material. So I'm going to right click and create a material. I'm going to call this M Fireburst, and then we will double click, which will open our material, and now we're able to start building our structure. So we need to get the local position, so we can feed the local position and subtract the local position from the object local bounds. So we're going to drag from here, type in a subtract, and then in here we need to add the object local bounds. And we can use the extents, the full extent of this, as I said, we'll also subtract the local position by the object local bounds. And we will then divide that subtraction by the minimum amount 3D pointed object bounding box. So we're going to put that in there and then the subtracting the A value like that. Now here is the point where we define the actual parameter of the texture. So we are actually going to look for sparse volume texture sample parameter. That's the one that you want, and not the normal one, not the texture sample. So once we have that, we can actually call this VDB input, because you can use the same material for other materials, although this is the main material that we're creating here. So so this one is the main material. You can use it for multiple VDBs, but you're going to have to create this one first, and then we can create material instances. And that's why we're using also a parameter. Now we've got that. What we want to do is now we need to basically divide this into the temperature and the density. So the density will go into our extinction, which we can't actually use right now because we've got to set the material to a what was it in here? This was additive, and then you gotta set it up in here. Sorry, not in there, in here, into the volume. So you got a volume additive. Let's just press apply. So now we've got an extinction, and we also have an emissive color and an albedo. So just very quickly for the albedo, just press 4 on the keyboard and left click. Keep 4 pressed while you do that. Connect it over into the albedo, and then set the color to white in this particular case, and then you can do whatever you want without that later. You can also convert it to a parameter and call it scattering color, like that, and just leave it. And then we've got to then set up the temperature, which will affect the emissive color, and then we also need the density for the extinction. Okay, now one thing to note in here is that we have our density on attribute A, which is that, if you remember when we imported, and we had temperature on attribute B and fuel on attribute, flames on attribute B as well. So we're going to use masking to subtract, to take those values out. So I'm going to search for a component mask in here. And because we want to do the density, we're going to deselect the green channel. We're just going to use the red channel. If you remember, the density was on the red channel. So we can actually take attribute A, plug it into here, okay? And we could bring this over into a multiply node like that. And then we can put in here, press S on the keyboard, keep it pressed, left click to get a scalar parameter. Hold this density multiplier like that. And we'll put that to a value of 1 default, and then connect that into the multiply node like that. And this actually goes straight into the extinction, and we're about done with that. Now you see we get an error in here, and that's because we haven't loaded up any texture. So you've got a slot here to do that. So, and that's the VDB. So I've selected it, and I'm going to press this arrow here to add it. Now you see the error is cleared. I'm going to press apply so far just to say, make sure that we lock that in. And now we need to sort out the temperature. Now the temperature was in attribute B, and it was on the R value. So I'm just going to duplicate this mask, bring over the this one like that. And now we're going to do a remap value range. Okay, and we need to set up the input in here is going to be this. And then we have an input low, high, target low, and high. So we're going to do this as, again, scalar parameters. The first one, a remap input low. And then we can put that in there. And then we can actually duplicate this and rename it. And this will be high. So basically getting the idea, right? We're just going to do that in there on each of them. So we can, add another scalar parameter, put that remap target low, duplicate, remap target high, and then we connect these. So this will allow us to have more control over the temperature and actually give us some really nice effects to work with. And then we need to have a temperature multiplier, so we're adding a multiply, and then drag that in there, add a new scalar parameter like that, call it temperature multiplier. Sorry, yeah, there we go, multiplier, and then put that in the B value, and then this into the emissive color like that. Actually, no, not in the emissive color, I've made a mistake there. We need a black body first, so let's get a black body. And we can actually multiply between the black body and a new scalar parameter, which is the black body intensity. We could call it intensity. Plug that in there and put this into the emissive color like that. So now we have an actual working material, or at least it should do. But we need to put some default values on these. So 1, then temperature multiplier to 1. And then here you want to keep the values between 0 and 1, and again 0 and 1 as the default state of this material. So now that this is done, we can actually start having to look at testing it out. Let's see what that looks like. Okay, so we're going to go back into our scene, and now it's time to drop in the VDB. So the way we do that, we go up here, press on the cube, and you can start typing HET, so sorry, HET, and this will be from heterogeneous volume. So you can drag that in your scene, and you'll see this dinosaur head over here, right? Which means that we've added the volume in. And if you look at the options in here, you do have an option to add the material. So onto the material, right click it, create the material instance. And now with the material instance, we can press this button over here to add it in. Okay, so now we've actually added a VDB in the scene. We do have some options in here, but we're going to go through the first most important ones for an animation, which is basically to play and for it to loop. And you're going to notice some odd stuff going on here, right? Because we're going to have to sort of fix this, right? We're getting some issues, and it's really good that we are, because now we can sort of work on fixing them into the material. So the first thing, we're going to go back into our material in here, and we want to look at what sort of mask we're using and what sort of attributes we're using as well. And also, very importantly, we've got to work out, in terms of if we've done everything in here as we should have. So, for example, one of the reasons why this is showing in so many places is because the material itself was set up wrong to begin with. I should have used the extent of the bound in here to divide it, and then the minimum over in here. And then when you press apply, you then have a look. Now it's actually properly generating. But then we get this massive flash, which is not really ideal. That means that the values that we've got are too big. So we can actually double click the material instance, and we can have a look at what we've got in here and what we can do to play around with these settings in order to get a proper effect. So I've got my material instance over here. I'm just going to drag this out so we can see it better. Now, if we start, enabling these settings, we can start playing around with them. You can see in here the Firebirds that we've added. Nothing really to do with the scattering color right now. We don't need that. But we've got to look at, what can we do to reduce the brightness and everything of this. So the first thing, we can actually go, if you go to temperature to 0, you shouldn't really get any more flashes anymore now, because we now have no temperature to this effect, as you can notice. Okay, now the black body itself could go to 0 as well, and then if you actually increase the temperature, nothing happens because there's no black body. So if we do a 0.1 on the black body, you'll notice it's still too bright. Okay, so maybe do like a 0.2 on the temperature, and that reduces that sort of effect. Now, one thing we could do in here, again, if you play around with these settings, you'll get some different values. And you can see, generally, it's just about pushing the boundaries on the temperature. Now, one other thing that we could do, we could go into the material in here, where we were before, and we can have a look at changing some of this. So, for example, maybe we want for the, for here, sorry, let me just put that back to default values. Maybe we want in here to, rather than sample the temperature from the attribute from the second attribute, maybe we want to sample the flame. So we can actually do that. So now we've got the green channel, and now we're actually sampling the flames for this effect. And as you're noticing here, we're not really getting anything. So it's time to have a look at what sort of temperature would actually produce the effect. 5,000 seems to be too much. Maybe 1,000. There we go. So this effect now is generated by the flame setting. Now, if you remember what I've said to you before, the flame attribute, yeah, is like 5% of the total material size. So if you want a smaller material for your explosion, then what you want to do really is just use the flames for the temperature and density, and don't get the temperature in as well, as an example, to reduce that. But that doesn't stop there. You could do some other experimentations. Like you could take the B and put it into here as well. And now we're using temperature and flames to create the effect. And this is looking a bit rough, I know. And that's because of some of the settings in here. But maybe, yeah, it looks like the temperature is really not working for us. So what I'm going to have a look is actually using flames as well. Let's see what that looks like. Now I'm using flames for everything. and it's not as great as with the density multiplier, but it's not bad. This is something. This effect is now generated by the smallest VDB part of it. Like if you actually bring in that VDB's file, actually I think I need to show you this. Let me just save so we're not losing our progress here. This is very important because again it just sort of emphasizes what you can get out of this, and you know how you can really manage your file size and your performance and so on. Let's just wait for this to save and then we'll resume. Okay, there we go. Now I'm going to create a new folder in here, and I'm just gonna say fire burst flames. Okay, so this is just the flames. So I'm gonna bring in here that VDB that we had earlier. You know, the one from here. I'm just gonna drag it in. So I can now import it again. This time, I'm actually just gonna say none to everything, and just bring in the flames. Just press import. The import of this will be a lot quicker than what it was earlier, because there's not that much information to be written as opposed to what it was before. Now, when I used those percentages earlier, maybe I'm a bit wrong with them, maybe I'm not on point, but I think you'll be able to, you know, sort of make your own decision on that based on what you're saying. So this particular fire burst here, let me just have a look if I could go to the folder, go to the folder view of this. Am I getting... No, I'm just trying to see where did my folder open, if anywhere. No, let me just... It should be in here, in content. There we go, and there, example math VDB tutorial. So this fireburst is 4.898 in size, and this one, I need to save it. So let me just save the map, and when you save the map, it actually does write the file. Okay, so there we go. Now we have it. So look at that. Fireburst is 700 megabytes here, but over in here, it's 4.8 gigabytes. That's the difference. This is what I'm trying to tell you. This is the difference. We're just using flames right now, okay? The flame effect. So you could go in here and drag that in, by the way. Like, you know, if we put that in there, we're now using just the fire burst from the flames, and that's it. There's nothing else there. And then you can play around with the parameters. Maybe go for like a, you know, 2000 is probably too much. 5,000 too much. 2000, that looks pretty cool. Generally, you'd want to like decrease the density so you don't really get a lot of artifacting. And then you can have a look at playing with the black body, because obviously this does even more. So, you know, I'm literally leveraging the flames of this effect. Now, obviously, in the project that I'm offering to people, I give them all the attributes so they can do what they want. But this is, you know, this is going to take you much further. Now, one other thing that we can do in here, let me just take the parameter away. There are some options in here. Like, I wouldn't play around with the volume resolution. I mean, this is, you could do that, but it's like effectively just changing the scale of the object. But then you've got frame rate, so you can have a frame rate, make the effect go a lot faster, for example. So that's really up to where you do the export. You then have things in here like MIP level. So if you increase that to like a 3 or a 5 or whatever, you're getting lower level quality, but at 0 you get the best quality of this and the lowest, you know, the biggest hit on performance. There's nothing for you to do in the physics as of now. Then in here where we've got lightning, you've got step factor, shadow step, and shadow bias. Now if you set everything to 1 in here, this is a very good balance of quality, overall quality, and you know, performance. So this is what you want. 1 on everything is really good. Now shadow, you don't actually get a shadow from this, just so you know. So that doesn't work as of right now, but maybe it will in the future. I'm not sure. Now other things that you could do is not in here, but more like in the light source itself. So if you go to the light source and type in vol from volume, default value of this is 1 here on the volume scattering intensity, and you can see how that looks like. It's a bit flat, and if you increase this even further, it looks even worse. Now, if I take this down to 0.25, I think like the fire really kicks in. And then also you got cast volumetric shadow. If you disable that, there won't be any sort of shadows from the directional light. Now, this is not very visible here, but when you're dealing with clouds, for example, that's a lot more visible. Let me just change the lighting conditions as well on this. So now we've got different lighting conditions, and you can see how that looks like. Hopefully, I'll be able to notice something. Yeah, it's very faint with the volumetric shadow on this, but it's definitely affecting it, right? And that's kind of how you set up the VDB explosion thingy. Now, what I want to show you guys is I want to show you the other project, which was in the example maps. It was this rolling fire, okay? So why do I want to show you this? Because this is made with the flame stuff as well. So if we go into the rolling fire, and we have a look at the material instance in here, and then from there actually opening the default material of this, the rolling fire is using two attributes. It's using density. Sorry, it's using flames for the temperature, and it's using this density here for the actual density, right? Now, if, for example, I would take I'm not sure what I've imported into it, to be honest, because you can't really tell now after you've sort of done the effect. Let me just see if there's any way to read the information. Unfortunately, it doesn't really say what you've imported in terms of attributes, which is a bit of a letdown that they just don't really say anything, unfortunately. But yeah, so this particular one that I've got, it does sort of it does have flames into the A value, in that mask. But let me just see what happens if I actually put the green one. So with the green one, I'm actually not getting anything. So that's because, like I've said to you, I don't actually have any other attribute apart from flames, which is in the R1, okay? Like that. But if I take the temperature instead, so let's say I take B, and I put that into the temperature, and now press apply. Let's see if we're getting anything here. Yeah, so this is what that looks like, but we do have it too intense, so we are going to have to go in here like that and decrease our black body, maybe our temperature as well, and just see how that plays like. I'm just gonna put this to 60 FPS, and it's still too bright, so maybe 100 in here. I can put a start frame to like 100, so it always starts at 100, and you can see it's not even really able to produce anything. So that's what it looks like with density only, no flames, right? I can add some density multiplier in here, and that's what it looks like when you do just density like that. So yeah, it's a bit of a different effect with that, as you've noticed. But I would definitely leave it the way it was, which was like this, and then no density whatsoever, but instead just flames, you know. And it's such a nice effect. It's really cool. I think it's really great. Something like that, just beautiful overall. But yeah, that's the power of flames. That's the power of temperature. That's the power of density. So remember, in your software like Houdini or Embergen and whatnot, make sure to actually export flames, because it's not a big deal to do so. It's not as costly in terms of disk size. It's the lowest thing that you can export, as opposed to temperature or density. And now one final lesson. It's all about your ability to actually see the effect. And what I mean by this is, like, right now we're watching a sort of a fire, and let's make this fire really big so we can see it from outer space. So it's really big, right? As you can see right there, the fire effect. Now, if I go very far away, fire disappears, pretty much, clips out, right? And this is a performance measurement, right? Now, if you want to be able to see that from very far away, then you actually need a console command. So that is r dot het heterogeneous volumes, and then you put a dot max trace distance. You can see that in there, and let's say, for argument's sake, I'll put that to 100,000. Now, as you can see, It's only at this point when it started disappearing. And all I need to do is just add another 0 and it's back up on there as well. And now it's going to disappear when I get to, well, I don't know. As you can see, we're still going and we still hasn't disappeared. Let me just, now it's disappeared. Okay. So as you can see, it's like it's almost becomes invisible how far away we are from it. But yeah, that's a very good way to be able to trace these from very far away. Imagine if you're doing a meteor strike or something like that. So yeah, I hope that helped. And that was the end of the tutorial. I hope you guys enjoyed it. I hope you guys learned a lot. Please leave a like, comment, and subscribe. Please let me know if there's anything else that I have not covered and you'd like to learn. Let me know if you want to see how I make my VDBs and how I actually get them ready for Unreal Engine outside in a different sort of DCC like EmberGen. I would be happy to show you if you're interested. But yeah, please feel free to share with me your work on Discord of what you were able to achieve with this information that you've learned today. So yeah, I would like to give a shout out to my patrons, to people on YouTube membership, and people who have purchased my projects and supported the platform so far. You guys rock, and I'm gonna see you in the next tutorial. So have fun.